Hey guys, welcome back. In this one, we're going to be training the actual neural network, which will later, in turn, allow us to make predictions of the Spanish, of the English or German text. Yeah, let's get started. What I'm going to be doing is completely just following this tutorial, but I'm not going to just type every single line. I'm going to be copy and pasting a lot of stuff. So go to this link. I'm going to post it in the description below, but go to this link right now so you can be copy and pasting along with me. Now, copy and pasting is of course not always the best practice, but I believe it is totally fine if you're just starting out. I personally believe that it is way better to make a few projects that you copy and pasted codes from different places, instead of like learning the basic math and then like being unmotivated because you never made an application of machine learning. But first of all, here's the code that I'm just going to straight up copy and paste. First of all, actually, before that, yeah, let me just delete everything. Show an external. By the way, this IDE I'm using right here is called Spider. It comes along with Anaconda. You can download Spider inside of Anaconda, and I really suggest using Anaconda for beginners because I think it's really easy to tune stuff like the virtual environments, because you can just it has a really simple GUI where you can create a new environment that specify the Python version, and then install new packages to that new environments. And then when you want to use that environment, you go back to the Anaconda navigator, you change the environment, and your spider will be automatically in that environment. And Anaconda comes along with other tools like Jupyter and RStudio if you're using R. But before that, let me delete everything besides DEUTXT because wait, I was able to delete that? I thought it would say something like file is open so you cannot delete. Okay, that's kind of weird. Alright, but first of all, get the DEU.txt from this right here. So download the zip, open it up, and then unzip it in your folder of choice. Yeah, the second file. There should be two files in the zip, and then one is just about me, and one is the other one. So if we take a look, this is what it looks like, right? So we have the English to the German mapping, or sorry, is this German? Yeah, this is German. Few things we have to do. As we can see right here, we got to prepare the text. We don't want punctuations. We don't want. I believe you don't want spaces, and a couple other stuff. And of course, the uppercase and lowercase. So to clean the text, to make it so that we don't have all of these symbols, let's open up a new file. Let's just save it as clean.py, just clean. And then, yeah, whatever, just copy and paste this, and I'll explain when we're doing it what this code does. Copy and paste this. If you don't have the if you don't have the packages right here, I believe everybody should have pickle, numpy, string. But if you don't have it, and you're using Anaconda, then just do conda install and then the package name. Or you can install pip inside of Anaconda and then use pip install, or you can just do in the global pip outside of Anaconda, and then not use Anaconda in that case. But I'm using Anaconda, so I did conda install to get these packages. So a couple functions, right? Helper functions. First of all is load a entire document, so we're loading this, and then we're gonna turn every single one of these lines to pairs, right? So we're going to make this into an entire list, and then we're gonna, make it into a list, and then we're gonna clean every single index of the list, which will be this pair, and then we're gonna append it to a cleaned array, right? This array is going to be cleaned. So at this point, clean pairs is going to be cleaned, and then we can just save the data. So yeah, let's run this. And then we're loading the file from deu.txt. Right, so everything should be good. Yeah, so it's right here. It is 0 bytes for some reason, even though it should be more. Oh no, it's printing something, so it should be fine. Yeah, so we're printing wait. Uh oh. Okay. But anyways, so if we print the okay. Oh, never mind, never mind. Yeah, so if we print the clean pairs, and then we print each index of the clean pairs, we can, and then we print the index 0 of each of the pair is going to be the English, and the index 1 of the each of the index 1 of each of any pair is going to be the German. So yeah. So as we can see, we have the mappings here. We got to split our pairs, our training data, into a training set and a testing set. So it seems kind of counterintuitive that it's a training data to train and test, but the reason that we have a test out of nowhere is because what when you're training a neural translation model or any neural network, what often happens is that your model overfits to the data set, and you can imagine overfitting as finding a best fit line that isn't going to be the best fit for the future examples. Right, it's really a best fit right now, right? Like it goes through every single data point, but it's not going to be good when a future data point comes in. So then we use a testing set in order to find out if our training set is overfitting or underfitting or other circumstances. So let's split our stuff right now. We're going to be splitting this English-German package, and I guess we can make a new file, whatever. Split. And then let's copy and paste this right here. Just run this, and then if it runs successfully, we should see this right here. Yeah, so the both and the German, English, German should be the same thing. Yep. Wait. Yeah. Okay, so now we can get to training with the test and train. I doubt that we're not gonna be using both. So for this, I'm also gonna just be copy and pasting the code, and then later explaining a few key functions that allows us to do the magical work. And if you're a web developer, I'm sure that a lot of people tell you that machine learning is a lot of math, but for implementation wise, you're going to be using like TensorFlow. I already have a train script for some reason. Let me save over this. You're going to be using a lot of libraries to do the work, so you don't have to implement everything from scratch, right? It would be stupid to do so. Let me just run this. It should work. Okay, so we can see our model right now. This is printed with the model.summary function. And where is that? Yeah, print model.summary. We can see that we have a few embedding layers and then LSTM layers. So I'm going to be explaining that in a second. First of all, I want to make sure that the epoch number 1 does run successfully. Okay, so it works. Alright, so let me go through a few key functions. So what you're seeing right now, the highlighted text, is where we actually are running all of this epoch thing, epoch 2. But first of all, we can see that it's model.fit, which means this fit function belongs to something called a model. So what is this model? This model is defined in, right here, define model. Yeah, I didn't even see this. Uh, Again, if you watched the last video, I talked about how we're using the LSTM, and I talked about that the state carries out throughout LSTM, making it really a best fit for sequential data training, or making a sequential data predictor. Um, so we have a LSTM and we have LSTM, but there's one thing that matters, but oh yeah, yeah. So the embedding layers, what the embedding layer does is it's another neural network. It's like a mini neural network inside of LSTM. It's another layer that allows us to capture um, how much each word contributes to the formation of another word, right? So in a lot of times in machine learning, you just like throw random neural networks to tackle even smaller tasks, right? And in our case, learning how much in sequential data, like if I say hello, my name is Andrew, my name is will probably contribute to the prediction that's actually that's a pretty bad example, but my name is going to contribute to maybe the prediction of S in Spanish. I don't know. Some sort of things like that. And embedding layer is going to help you to determine how much each word contributes to another word. Uh, and then so yeah, you have the model, and then you have the training set right here, and then you have the testing set right here. These are easily used if you just do model.fit. The batch size is how many examples are trained at a time. Usually people go with two, I mean not two, to go with a basis of two, or you can go with one, which is stochastic. Epochs 30, whatever, that means how many times you're repeating the cycle. Validation set is a test X, whatever. Let me see. Yeah, so this thing right here, checkpoint, equals to model checkpoint. What that would do is to be saving the model. The model is going to be model.h5, so that's where the actual model exists. And the model is really just a bunch of numeric numbers and that have weights to it, right? What else should there need to be explained? Oh, tokenizer. Yeah, tokenizer. So, if you just cannot directly map from A to like C, right? You have to convert it to numbers first. Or Andrew to hello. I don't know. I mean, hola to hello. You can't just directly map the letters themselves. You have to convert it to numbers first that don't really that don't really have any meaning tied to them. But then you create this neural network, and then the mapping allows them to create relationships. And the actual line is this a helper function? So I gotta find create tokenizer. Yeah, so this thing right here allows us to do that tokenizer.fit on text, and then the text that we want to fit. Yeah, that's really it. In a couple of minutes, you should be done with the neural network of training. And I guess at that point, we can just put it into the website. So see you guys in the next video.